Hi guys, in today's video we're going to take a look at crystals. We'll look at ionic structures, metallic structures, macromolecular structures and molecular structures, an exam style question and finally a summary.
Before we take a look at specific structures of crystals, let's take a look at what exactly crystals are. Well, crystals are solids with a regular arrangement of their atoms, and they're held together by forces of attraction. These include bonds, which can be either ionic, covalent or metallic bonds, and intermolecular forces of attraction, which include hydrogen bonds, London forces, and dipole-dipole forces of attraction. So let's begin by looking at our ionic structures. We know that an ionic bond is the electrostatic attraction between positive and negative ions, that's oppositely charged ions. Well, our ionic structures exist in a lattice. Now within that lattice we have a regular pattern of oppositely charged ions. And those ions are indeed held together by the strong electrostatic attraction between those oppositely charged ions. So if we were to look at an example of sodium chloride, sodium chloride is composed of positively charged sodium ions and negatively charged chloride ions. Now each sodium ion is ionically bonded to a chloride ion, as you can see here. But as we discussed, ionic structures exist in this 3D lattice, so we have this regular and repeating pattern of oppositely charged ions. Now our ionic structures have high melting points. That's due to the fact that the strong electrostatic attractions extend throughout the structure, throughout that 3D lattice, and lots of energy is required to break these strong bonds, allowing for melting to take place. Interestingly, our ionic structures are also electrolytes. This means that when dissolved in water or when molten, the ionic lattice breaks down and the ions are free to move. As our ions are free to move, they can carry charge, which allows our ionic structures to conduct electricity when in an aqueous solution or when molten. So now we've had a look at our ionic structures, let's move on to a different type of structure. If we then have a look at our metallic structures. You may know that metallic bond is a strong electrostatic attraction between positive ions and the negatively charged delocalized electrons, that sea of delocalized electrons. So in our metallic structure, the metal ions are held in a regular lattice. If we take a look at magnesium, you can see that regular lattice here. Now for every positive ion, we have 2 delocalized electrons. And if we take a look at the melting temperature of magnesium, we'll see that we have a high melting temperature. And this is because these strong metallic bonds exist throughout the structure of our metal. Now, as we have these delocalized electrons throughout our structure, which are able to move, our metals are able to conduct electricity. If we then go ahead and have a look at our macromolecular structures.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, just click the Snap Provide smiley face. Join me today and together let's make A-level chemistry a walk in the park.